Hello, today we are going to use Newton's law of cooling to solve this problem. You visit an outdoor shooting range located near a lake which houses a large amount of ducks. Your line reservation time is from 1:30 to 3 p.m. After 30 minutes in the shooting range, an employee accuses you of shooting and killing a duck, which is strictly prohibited. A nearby forensics agent volunteers to determine who shot the duck. The duck was shot with a caliber .22 bullet. Records indicate that 4 persons used a .22 caliber earlier that day. Kirk was at the range with a .22 from 11 a.m. to 12 p.m., followed by Lars from 12 to 1. Then James from 1 to 1:30, and finally you from 1:30 to 3 p.m. The agent took the duck's body temperature at 2 p.m. and recorded 102 degrees Fahrenheit. An hour later, its temperature was 98 degrees Fahrenheit. The outside temperature that day was a perfectly steady 85 degrees Fahrenheit throughout the whole afternoon. If a duck's normal body temperature is 108 degrees Fahrenheit, determine who shot the duck. Alright, so we're giving a bunch of information right here. First, the duck's normal temperature that is when they are alive, is 108 degrees Fahrenheit. Okay? We then record the duck's temperature. We first recorded at 2 p.m. At 2 p.m. it's 102 degrees Fahrenheit. And it says here, an hour later, let me see, where did I write it? 30 minutes, strictly prohibited. At 2 p.m., recorded 1 and 2. An hour later, the temperature was 98 degrees Fahrenheit. So duck's temperature at 3 p.m., an hour later, is 98 degrees Fahrenheit. Okay, 98 degrees Fahrenheit. One more temperature we have is the outside temperature. The outside temperature that day was a perfectly steady 85. Outside temp was 85 degrees Fahrenheit. Okay? So these are the temperatures we're going to need. There are 2 formulas that involve Newton's law of cooling. The first one is d capital T over d lowercase t. Okay, and this is going to equal to negative k, that's a constant, T minus temperature surrounding. Okay, the second one is going to be T of lowercase t equals temperature of the surrounding plus temperature initial minus temperature surrounding times e to the negative kt. Okay? To begin, we know that d of capital T over d lowercase t is approximately the change in temperature over the change in time. Change in time right here. So we can determine that delta T over delta lowercase t. That would be change in temperature. So between an hour that passed by, there was a change in 4 degrees Fahrenheit. We lost 4 degrees, minus 4 degrees Fahrenheit over change in time was 1 hour. So we're going to use 60 minutes here. 60 minutes. So that's what delta t over delta lowercase t equals. Okay? Now using this formula, we can use this as this right here. So negative 4 over 60 equals negative k. The temperature initial was 102. And the outside temperature of the surrounding, is 85 degrees. Okay? So we can then calculate 4 over 60 equals 102 minus 85. That would be 17. Okay? Now, what we can do is we're going to divide negative 4 by 60 and then divide that by 17. So this would be a negative. This would be another. Let's solve for that, okay? Let's see what we're going to get. Negative 4 over negative 4. 1 second. Negative 4 over 60 equals. Here's what we can do. There we go. Easier. Why complicate ourselves? So we get, if we solve for this, we get negative 0.00392. 92 equals negative k. The negatives cancel. Okay, these negatives are going to cancel. So k equals 0.00392. So now that we solve for k, we can go back to our formula over here. We're going to plug that in there. And we can solve for the time. Okay? So T of t initially was 102. 102 equals surrounding temperature is 85 plus initial temperature was 108 minus surrounding temperature again, 85, e to the negative k. We found negative k over here. Negative k is going to be 0.00392. And t. We're going to be solving for t right here, which would be the time. Okay? So, what we can do here, we're going to subtract 85 from both sides. That's going to give us 17 equals 108 minus 85. Let's solve for that. 108 minus 85. That'll be 23. 23e to the negative 0.00392 t. We can get rid of this 23 by dividing both sides by 23. So we get 17 over 23 equals e to the negative 0.00392 t. It's a parentheses. Okay, how do we get rid of this e? What we can do is we're going to take the ln of both sides. So ln of 17 over 23 equals ln of e to the negative 0.00392 t. That's going to cancel this e, so we're left with ln 17 over 23 equals, it's going to cancel there. We're going to equal with negative 0.00392 t. Okay? Last step, we're going to take this and divide it by this to get rid of this. That's going to leave us with our t right there. So let's do that. ln t equals ln 17 over 23 over negative 0.00392. That gives us T equals, give me 1 second, ln 17 over 23, and you divide that by negative 0.00392. That is 77.11. Yeah, one more significant figure right there. So that's the time that it took from the initial temperature, which was 108 degrees Fahrenheit, to go to 102. Okay? Okay, this is minutes. Okay, so the duck died 77.112 minutes before we took the temperature at 2 p.m. Okay, we can determine, let's write this back here. Okay, the duck died 77.112 minutes prior to 2 p.m. Let me do a quick calculation over here. 77.12, so 2 minus 60, 27. That's gonna be about 12:42 p.m. 77.112 minutes before 2 p.m. is about 12:42 p.m. Okay, so who were the people who had 22 caliber? There were 4. We had Kirk, we had Lars, we had James, and we had you. You were there too. Okay, the times, 1 second. So Kirk was at the range from 11 to 12, then Lars from 12 to 1. 11 to 12, then Lars from 12 to 1. These are PM, by the way. PM. What time was James there? Then James from 1 to 1:30, and you from 1:30 to 3. So from 1 to 1:30, my mistake, sorry about that. He was there from 1 to 1:30 p.m. And you were there from 1:30 p.m. to 3 p.m. 12:42 p.m. was when the duck died. So we can determine 12:42, that would be Lars. Lars shot the duck. You are innocent. Congratulations.